And remember that we're gonna start the lesson that I kind of gave you an intro last time, but we didn't really do any problem. So having there your 4.8 notes, those are the ones that we're gonna use. I'm gonna start sharing the screen with you. And wait, I was looking at something on the homework, so that's why I had that in there. So 4.8, remember that this section is called antiderivatives. You already know how to do derivatives, and you know certain formulas for taking the first or the second derivative of a function, right? And if you remember, we know the power rule, the quotient rule, the product rule, and then there's derivatives, special type of formulas for derivatives, like what is the derivative of ln of x, what is the derivative of e to the x, and stuff like that. So in order for you to do a derivative of an equation of a function, you needed to be given the original function, and then using the formulas for the derivatives, pues you would apply whatever formula was needed according to every problem. Well, here imagine that we're gonna go backwards. When you're finding the antiderivative of something, you in reality, what you're doing is you're given the first derivative of an equation, and you wanna go backwards to find out what was the original equation to whom, if you take the first derivative, you get that equation. So what you're gonna be given is gonna be the first derivative of an equation, and we're gonna go backwards using some formulas to figure out what was the original equation whose derivative is what was given to us in the problem. So to start off, every time that you're finding the antiderivative, every time you're going backwards looking for what was the original equation whose first derivative is what's given to you, you're always gonna have to add a constant at the end. Capital F of x is gonna be representing that equation that you're gonna be looking for, that antiderivative equation you're gonna be looking for. And you're always gonna have to add plus c. Sometimes you actually know a specific value for the constant, a specific number for the c. It will be given to you on the problem, and sometimes you don't know it. So, but anyway, if you don't know a specific number for the c to be, you have to always remember that you have to just write down actually plus c, plus the letter c, and that should be enough. But when you go to the homework in MathExcel, when you're looking for antiderivatives, it's not enough to only come up with the equation of the antiderivative, but you also need to put plus c, because if you don't put plus c, the answer is going to be counted wrong. In the case that you don't know a specific value for the c, you need to always have the plus c letter. But if you are given a specific number to replace the c by, then you replace it obviously by that number. So here are the formulas that I'm not needing for you to memorize these formulas, okay? These formulas, you're always gonna be able to use them from the notes when doing a homework or when doing a problem here through the Zoom or whatever. So what you do need to understand is how are these formulas going to work out? So the column where it says function, right? And there's two columns that say that 1 through 7, 8 through 13. That's what it's gonna be given to you on the problem, okay? So you can be given anything in the format of 1 through 7 or 8 through 13 in your problems. The antiderivative of each of these formats of formulas, let's say, that you're gonna be given, it's what you see to the right-hand side of 1 through 7 or to the right-hand side of 8 through 13. So for example, if I have an expression that I'm gonna be asked, find the antiderivative of this. And the equation that's given to me looks like, let's say, something like number 1, x raised to some number. What would be the formula that I'm gonna use to write down the antiderivative of x raised to some number? I'm making reference to number 1. You're gonna use the formula that is right across it, right in front of it. This is the formula that you're gonna go by, where it's not that difficult to follow the formulas. I know that it looks like a lot, but I mean, it's just a matter of following the pattern of the formula. So this n, you see here, that is being used to represent what number is gonna be on the exponent or what expression is gonna be on the exponent. It's the same n as every n you may see on the actual general antiderivative formula. And look how every formula for the antiderivative of no matter what you're doing always has plus c, because I'm telling you that you're supposed to always have a number to put into that constant place. But if the number is not given, you're just gonna let it be exactly plus the letter c, and that's it. So anyway, let's put this formula, some of these ones, into practice. So for example, this one, I forgot to open the program that allows me to write. Let me do that. Okay, so let me take a screenshot of this problem. It says, find the antiderivative of the function -11 sine of 11x. This is the angle 11x of the sine, right? And this is just a number that's technically multiplying times sine of x, -11 times this. When the c is gonna be a 0, so in this case, they're giving us a specific number for the c to be, okay? And sometimes they're gonna tell you when c is this other number. And sometimes if they don't tell you, you're just gonna let the c be in the letter c. But in this case, the letter c is gonna be a 0. So what you're gonna do, the antiderivative of this function, you're always gonna represent it with a capital F, okay? Capital F of x. If this was, let's say, an h, like h of x, the antiderivative of this, you're gonna use a capital H. So the capital letters, in terms of the function g of x, capital G of x, h of x, capital H of x, that's what the antiderivative is gonna be. So what I need to do now is -11. Okay, so this is just a number that's multiplying times all this. So what's gonna happen with this value that it has no x, it has nothing, it's just a number. So there is actually in this notes that you have here, there's one formula that is missing, and it's simple, but I don't know what's the reason that it's missing. So in order for me to write it down in there, I'm gonna take a screenshot, and I need you to add this formula on your own. I don't know if you wanna make it to be number 14. So rule number 14, what would be the antiderivative, the general antiderivative of an expression that is just a constant? This is gonna look as k times x plus c. Okay? Every time you have a constant, what's a constant? Is just a number. But this constant, be very careful. This constant has to be a number that it's either adding or it's either subtracting to something else for you to consider it a constant. The number that I was having right now, and I'm already telling you because I know at some point I'm gonna need this formula for one of the problems we're gonna do, at least for one. But in this problem, the -11, if the -11 was adding or was subtracting with sign, then for doing the antiderivative of the -11, then you would use formula number 14. This k would be your -11. But if the -11 is not adding or subtracting with the rest of the things that are there, in this case, it's just multiplying, don't use any formula for this. All you're gonna do for the -11 is you have to bring it down here as part of the answer. That number that's multiplying times the entire thing, you're just gonna let it be part of the answer. Nothing's gonna happen to it unless that -11, as I said, was adding or subtracting with this. Then I would do the antiderivative of the -11 by following this formula, but I'm not gonna do it for that one because it's clearly not addition or subtraction. What's going on between this and this? So I bring this number that's multiplying times this to the answer. That's already gonna be part of the antiderivative equation. Now my focus is going to be on this, sine of 11x. So if I go to where the formulas are, let's find out which formula can be used to write the antiderivative for sine of whatever angle. So you're gonna look on the 1 through 7 or on the 8 through 14. Where do you see sine? Well, I see sine here on number 2, sine of kx. What's the k here? A different number every time. In my problem right now, the k, it's this 11 that is in front of the x or before the x, okay? So this is the formula that I'm gonna be using, and I'm gonna copy all this formula here. So I'm gonna be using, where do I have enough space? Here to the right-hand side. Sine of kx, the antiderivative for this, it's going to be this one, -1 over k, here, -1 over k, and I think it's cosine after that. Cosine kx plus c. Cosine kx plus c. I don't know if they had the parentheses on the kx. No, they didn't, but it's the same. You may put the parentheses, you may not put the parentheses. it's really up to you, okay? This doesn't make a difference. I'm gonna just take it off to write it the same as in the formula. Cosine of kx being the angle that's gonna go there, and then plus c. So based on this formula, what I have right now, sine of 11x would be like this part, right? So sine of 11x, and all you have to do, and then I'm gonna copy this here with my equation. It's gonna be right, -1 over, what's k? K here, it's an 11, right? And the formula had a negative here, so I need to make sure that I bring that with the formula. Cosine of k times x. What's the kx in your original sine problem? It was 11x plus the c. That's it. That's all you do. Sine of whatever angle, look for it in the formulas, but obviously on one of the left-hand side columns, identify what's the formula that goes with it. What is the formula for the antiderivative of that? Just plug in everything, specifically the k is the one that was playing an important role in this formula, and the sign changes to cosine. So then now you see all this is the antiderivative of only this part. But my original equation that was given to me, which by the way, this represents the first derivative of the equation that I'm coming up here with, also was involving the -11. So completing the whole thing, you keep the -11, and all this that we did here, using the appropriate formula for the antiderivative of sine of 11x specifically, you're gonna put it here. So the -11 was originally multiplying times this, so the -11 is gonna multiply times whatever the antiderivative of this is, which is this now. -1 over 11 cosine of 11x plus c. What's the only thing here left to do? And this is not a minus. I know that I made it too big. Look, you may think this is a minus like subtraction, but it's a negative. So -11 is multiplying times all this if you want to see it like that. So the only thing that I would do to simplify this is multiply the -11 times this number, okay? Don't try to multiply it times this, because this is the angle of the cosine. The angles, you never touch them, you never change them. But these two numbers, you can multiply them. So a negative times a negative is gonna make a positive. And you know that these 11s are gonna cancel. So negative times a negative makes a +1. Do you really need to write the 1? No, you don't need to. You know that at the moment you write cosine of 11x, there's a 1 here. But I mean, it's really not needed for you to write down the 1, which is the answer of the multiplication of these two. So cosine of 11x plus c. Now, what was my c? My c was given to me as being 0. So if I actually replace, and you should replace, if you're given a specific number for the c to be equal to, and you type this on Math Excel is gonna say, this is wrong. If the instruction was given to you like this, your last final answer should have on the c the replacement of that number or whatever value they're giving you. So cosine of 11x plus 0. To me, this is fine, but if you wanna, like, you know, adding a 0 or subtracting a 0 does not change things at all. So then final simplification for this problem can simply be this, because plus 0, it doesn't make a difference. Unless the c was a different number, then yes, you want to make sure you include it, right? Plus whatever the other number may be. But if not, this is the answer, right? Not that complicated. All you have to do is look at the format of your given function, right? And understand that this is the first derivative of some equation. So what you're doing is you're going backwards and you're saying, okay, this is the first derivative. So the original equation from where this came from, it's actually this one. If you actually take the first derivative of this is the answer that you should get, okay? But now we're going backwards. So questions so far on this problem? Anyone? No? Okay, so I'm assuming that we're okay, that we're doing good. Let's do another problem. So that was this one. Let's try this one. Okay. So now I need to find the antiderivative of this given function when c is going to be 0. So what are you going to do? Observe what you have. 5 is multiplying times this cosecant of x. Cosecant of x is multiplying times cotangent of x. So when I'm going to find the antiderivative, first of all, this number that is multiplying times anything that may be there, any number that's always multiplying times something, all you're going to do with that number is what? Bring it down. That's going to form part of the answer, okay? That has to be part of the answer. Now, focus on this. Cosecant x, cotangent x. So here to the side, I'm going to write down what formula am I going to use for the derivative of something like this. Cosecant x, cotangent of x. So I go to the notes. Where was it? There. Look for in the 1 through 7 or the 8 through 14 column, cosecant of x, cotangent of x. This one, cosecant, cotangent of x. So then the formula that I'm going to use this time is number 7. I have something in this format, cosecant of kx times cotangent of kx. The k is going to be whatever the value is before the x, which in this case, you can assume that the value before this x is a 1, the value before this x is a 1, unless you see another number that would be your k, right? So for cosecant of, and I should probably put the k, of kx times cotangent of kx, what is the antiderivative? How is it going to look like? Where was it? Here. So the antiderivative is this one, negative 1 over k, multiply that times cosecant of kx plus c. So let me take this to the other slide. Negative 1 over k, negative 1 over k times cosecant of kx plus the c. If you see, I just copied exactly what's here. So in the problem that I have cosecant of x times cotangent of x. What's the k? It's a 1. If you don't see any number before the x plus, you assume it's a 1. So then the antiderivative is going to be negative 1 over k. What did I say is the k? It's the number 1. Cosecant of, and here I missed the x. I wrote this too fast, I think, and I missed it. Kx plus c. Cosecant of kx, what's going to be my kx? Pues the 1x. So just x, you don't need to write the 1, plus the c. So simplified version of this, what's negative 1 over 1 in this particular case? Pues just negative 1. So negative 1 cosecant x plus c. Do you want to put negative 1 or do you just want to put negative cosecant of x plus c? Both are correct. So I would use, I think, this one instead. This one better. So that's what I'm going to bring in here. 5, the 5 that I said I had to bring to the answer, times the antiderivative formula of this, which came out to this simplified format. So times negative cosecant of x plus c. And this is not a 5. It looks as a 5, but it's an s. What's the only thing that I see here left to do to say this is my final answer? I would leave my final answer as follows. You already know that this 5 can multiply times all this, or should multiply times all this. And I already know that this negative, it's like if it is a negative 1. So when you distribute 5 times a negative 1, pues that's just going to be a negative 5. Copy the rest. Cosecant of x plus c. Now what's the c? The c is 0 in this problem. So my final answer should be negative 5 cosecant of x. And if I replace the c by the actual value of c that's given to me on the problem, the c should be a 0. But you know that zeros adding or subtracting to anything, they're not really necessary to appear. Like you don't need to actually write down the plus 0 part. So just like this. And I hate the way that I'm making the s look like everything except as an s, look like a 5, look like an 8. So this would be the answer. Negative 5 cosecant of x. Okay, that's the antiderivative. That's what you were looking for all this function. Let's do more. This one. So find an antiderivative for each of the functions. In each of them, you're going to assume that C is 0. Okay, so every time when you finalize the antiderivative formula, make sure you plug in the 0 into the C, and basically you don't need to write the C anymore because in this case, the C is going to be 0. So for the first problem, okay, for letter A, I need to see what's the antiderivative formula for e raised to 9x. So I'm going to go here. E, look on this column. E raised to something. No, we don't have that formula here. Number 8. E raised to kx. This is the formula that we're using for the antiderivative. E to the 9x, so the k is going to be like the 9, right? So I'm going to copy those two formulas over here for this one. So I'm going to put here e raised to the kx. Oops. The kx. And the formula for the antiderivative, I'm supposed to be for 1 over k times the same thing, 1 over k times e raised to the kx plus e. 1 over k raised times e raised to the kx plus the c. So my formula right now, it's e raised to the 9x. So what I have to do is come up with the antiderivative with a capital F and just use this formula. So 1 over k, what's my k? It's a 9 times e raised to the original kx. So e raised to the 9x plus the c. What's going to be the c? I'm already going to do the substitution of c by the number 0 plus 0. So final thing, you don't need the plus 0 there. 1 over 9 times e raised to the 9x. This is okay. What's another way you can write this answer and it should be counted as correct on Math Excel? You can either write 1 over 9 and then leave a little, like do to the right-hand side with a right click or something and start typing this. Or you can find this written as a single fraction. Imagine that you put this e raised to the 9x over 1. What if you put it over 1 and you multiply the numerators and you multiply the denominators? That can also be. So 1 times this, e raised to the 9x, 9 times 1, 9. To me, both answers are correct. Either this, where you didn't have the over 1 yet, or either this. Both are the same thing. Okay, so that would be for letter A. Now for letter B, I think it's the same formula. I mean, it's just e raised to something. So we're going to use the same exact thing. E raised to kx, your k is a negative 9. And you're going to do the formula 1 over k times e raised to the kx plus the c. So then my antiderivative, and this time is not going to be capital F. This time is going to be capital G because the given function was a lowercase g. So capital G of x and 1 over, but the k is a negative number. So 1 over negative 9 times e raised to the negative 9x plus the value of c that is given to me is 0. So this, the best way you can write this, what's a positive from the 1 divided by a negative from the 9? So positive divided by a negative, it's a negative, makes the entire fraction to be negative. I would write the negative at the very center of the fraction. That shows that you divided the signs. Times e raised to the 9x, because you don't need the plus 0 part. Either you leave the answer like this, so this is fine, or, oops, that looks so bad. Or you can do what I did here in this problem before. You can say, okay, so the fraction is negative. So negative, what's 1 times this? The same thing. Imagine there's a 1 here as a denominator. So 9 times 1, just the 9. Okay. So I'm not writing the over 1 because I mean you can see from here that it's the same thing. These two can be the correct answers for this problem. For letter C, it's just different types of things you may have on the exponent. But I mean, it's actually the same thing. The only thing you're gonna do here, e raised to x over 10. So to write this in a way that you may be able to see it better, my exponent is this fraction, e raised to x over 10, okay? This can also be written as the following, e raised to the 1 over 10 and the x next to the 1 over 10. Where am I getting the 1 from? The 1 is right here, even though we don't see it. So if you want to know what your k is in this formula, in e to the kx, the k, it's 1 over 10. Okay. So we're going to use the same formula again. So my antiderivative, it's going to be 1 over, now be careful, what's the k? The k is not only 10, the k is not only 1, the k is the fraction, 1 over 10. So the entire k gets replaced by the entire 1 over 10. So 1 over k is here already. Now e raised to the original, you can leave it as x over 10 if you want, or 1 over 10x, it's the same thing. I'm gonna go back to the original format. E raised to the x over 10, just because I think it's easier to write it like this, plus the value of 0, because that's what the z was supposed to be. Now, the only thing here is simplify this. 1 divided by this, well, you know that you can change this into a multiplication and do the reciprocal of the 1 over 10. Put it as 10 over 1. Copy the rest of the stuff as they were. This was a 0. So, f of x equals, when you multiply this, 1 times 10 is going to be 10, right? What if you think of this as a 1? So you multiply the numerators and denominators. So this is going to be a 1. 1 times 1, 1. E raised to the x over 10. And the 0, I'm not going to write it anymore. Actually, I didn't have to in this step. I could have just skipped writing the 0. So 10 over 1 is simply a 10. So the final simplification of this antiderivative, it's going to be 10 e raised to the x over 10. Okay? And that would be my final answer. Like, there's no other way to write this. This would actually be the only way. Not like the other ones that have maybe more than one way. This would be it. Okay. So far, any questions on the use of the formula for finding the antiderivative of e raised to something? No? Okay. So I'm going to continue. The next problem. Okay. So up to here. Look at the instruction. Find an antiderivative. Everything that I was doing, it was the same instruction. Find the antiderivative of whatever when c is 0. The next type of problems we're going to do, you're doing the same thing. It's practically the same exact thing. What's the difference then? The difference between the problems that I just did right now and the ones that I'm going to start doing is that now these problems are going to have a symbol. This symbol you see here on the screen, it's called the indefinite integral. It's the symbol that represents for you to find an antiderivative. So the instruction may say now, find the integral of this equation. Or it may say, find the antiderivative of this equation, but at the same time, you're gonna see that symbol. Just be aware that that symbol, it's the same thing as finding the antiderivative. It's just before we didn't have that symbol in the previous problems that I did, but now get used to seeing it. So that is the integration symbol. Integration is the same thing as antiderivative. Antiderivative is the opposite of getting the derivative of something. So integration is the same thing as an antiderivative. Whenever you read, find the integral of whatever, find the integral means find the antiderivative, okay? Just be aware that the word antiderivative, as you can see here, the collection of all antiderivatives of a function is called an indefinite integral. This symbol, it's the integral symbol, integral like this, but it means nothing more than doing the antiderivative of a function, but you have to do it piece by piece, part by part, in the case that the problems are longer. So here is an example where we're gonna apply how to do the antiderivative or how to integrate this function piece by piece. So it says, find the most general antiderivative. You're still doing the same thing. Or indefinite integral. Same things to each other. But now because you have this symbol, they're mentioning the words indefinite integral because that's the name of the symbol on the equation. Check your answer by differentiation. What is differentiation? Check your answer by taking the first derivative of the answer you're gonna get, of the answer. If you get the first derivative of the answer and you obtain the equation that you were given as a result, that's your way of checking that you have done the antiderivative or that you have integrated this correct. If when you say, okay, this is my equation for the antiderivative, this is my equation after the integration, take the first derivative of that result, and if that takes you back to this, that means you have done it correct. So let's go by parts here. You have to do the integral or find the antiderivative of 2x to the fifth minus 5x plus 9. So every time you have a plus or minus in a function, treat that term that is after the plus or after the minus as a separate term. So what you're gonna do here is you're gonna rewrite this in the following way. The integral of 2x to the fifth power, this dx you see here is just a symbol that goes together. When you have this integral, this needs to be here. If your equation has x's, you're gonna have a dx here. If your equation has, I don't know, the letter t, instead of x's, you're gonna have dt here. This just indicates with respect to what letter are you doing the integration? Well, with respect to x's, because that's the only letter that I have. So the integral of 2x to the fifth with respect to x minus, because that's the symbol that you have, minus the integral of 5x with respect to x, because that's the letter that this little tiny expression has, plus the integral of 9, and I know it doesn't have an x, but everything was written in terms of x's, so you're not gonna change that. So now all I did here is I broke it into smaller pieces. This big integral that I have to do, or this antiderivative that I needed to do, I'm doing it step by step, one at a time. So I'm gonna look for what formula from the formulas that I was using right now could I use to find the antiderivative for this first part. So 2x to the fifth power. This to me looks like it could be written as, or I could use the power rule. So if I go here, I have 2x to the fifth power. So right now, I'm saying let's use this. The 2 that is multiplying times the x, what are you gonna do with this 2? Nothing. You're just gonna bring it down. 2 times whatever the formula is you have to do for x to the fifth power. So what's the formula? X to the fifth power is like x to the n power, okay? So I'm gonna do for x to the fifth power, hopefully it fits in here, x to the n, formula for the antiderivative of x to the nth, it's 1 over n plus 1, 1 over n plus 1 times x raised to the n plus 1 as well, you see? And then the plus c. This n cannot be -1. It's just giving you a reason or a restriction that n, this exponent, it's never gonna be given to you as a negative number, okay? That's all that it's saying. So don't forget the plus c here. So in x to the fifth power, the antiderivative would be 1 over 5 plus 1 times x raised to the 1 plus 5 plus the c. So when you simplify this, 1 over 6 times x raised to the 6 plus c, right? What's my c? Notice how in the instruction, nowhere they gave me a value for the c. So I don't know what c may be. That just means that at the very end, your final answer should have plus c as you hear it, as you see it. You're not gonna just ignore the fact that, c is gonna be a 0 like in the other problems. No, because that's not being said in here. So the only thing that I'm gonna do is leave the plus c part until the very end. I'm just gonna put one time the plus c for my final answer. I'm not gonna be putting plus c for this, plus c for, like, no, just for the final thing. So the 2 that I had to bring down times the antiderivative of x to the fifth. What's the antiderivative of x to the fifth? Is right here. So times, I'm gonna put a parenthesis, 1 over 6 times x to the 6th power. Don't copy the plus c. We'll just put a plus c for the whole thing at the very end, okay? Obviously, I'm gonna simplify this, yes, but this is already completely what the antiderivative of this whole thing should be formed by. Now I'm gonna continue, bring down your minus. And now I'm gonna do, what's the antiderivative of this? Well, the 5 is just a number that you have to bring down. And notice that when I'm already doing the antiderivative, I'm not writing this symbol anymore. You don't need it because you're already doing what this symbol is telling you to do, which is do the antiderivative or do the integration. So basically here, just do the antiderivative for x. What's the formula you're gonna use for x? The same one that I have here. X to the first power, because that's the exponent that you have here, is gonna be like your x to the n power. And then you use this formula, okay? So same formula I'm going to use for this one. So I'm already gonna write the answer here. I'm gonna put 5 times. So the formula says 1 over n plus 1. What's my n? It's a 1. So 1 over 1 plus 1 times x raised to the n plus 1. What's the n? It's a 1. So 1 plus 1. Plus the c, obviously. But I mean, I'm telling you, we're not going to be putting the z right now until the final answer. So the simplification of all this is what's going to be the integration or the antiderivative for this one. Now we continue. So now plus, okay, this one here. What's the formula for integrating a constant value? And that's the formula that I told you. Add this formula because it's not there in the formulas that were here. So I added as number 14. The 9 that you have to do the integral of right now would be like the k. Okay. So this 9 is like this k right now. So k times x plus e is the antiderivative formula for this. So I'm gonna copy this formula in the other problem for this one. So for this one, when you have to just k, just a number by itself, and you have to do the antiderivative of a number, a constant just like that, it says that the antiderivative is kx plus c. If you see, all I did is copy this. Okay, so then the antiderivative is kx. So the k is the 9. So the formula tells you basically just put an x next to the number that your k is. So if my k is 9, the antiderivative is 9x. Okay. Now plus the c, but I'm not writing the c. Okay. So this was my first step. This is my second step. All I need to do now is simplify all this. How do I simplify? Please just do the proper multiplications or whatever. So 2 times 1, 6. It's going to be 2 over 6 x to the 6. This can be simplified more, this fraction. I will do it in the next step. Minus. Here, 1 plus 1 is going to be a 2, right? So 1/2 times 5, it's going to be 5/2. X to the second power. The 9x, all you're going to do is bring it down, adding plus 9x. And the only thing that I would say, don't stop here, because if you type this in MATLAB, in Math Excel, saying this is my answer, for 2 reasons, they're going to count this answer wrong. One reason, this fraction needs to be simplified. Anything that you are still not done simplifying, and you type the answer like that, obviously it's going to be counted wrong. So how can I simplify this? What if we divide both numbers by 2? So then this would turn into 1 over 3 x to the 6th power minus 5/2 x squared plus the 9x. And the second reason that they would have counted this answer wrong, not only because of the simplification that you were missing to do on the 2 over 6, but also because you always need to have plus the value c. If the c is not given to me as a number, it doesn't matter. But if you don't type plus c on a problem like this, where you're doing the antiderivative or the integration, in the case that you're not given an actual number for c, then your answer is gonna be counted wrong more than likely. So this would be the actual antiderivative or the actual integration, complete integration of the given function, which is the same thing that we were doing. I just broke it into pieces for you all because this one had more terms, more than one single term. Okay, but using the same formulas, that doesn't change the same set of formulas that I'm referring back to every time. Let's do more that have the integration symbol. So for this one, for example, find the most general antiderivative or indefinite integral. Okay, so first of all, what would I use for something like this? Well, if I go to the formulas, x raised to some number, that's what this is, right? x raised to some number. I think I would go back to number 1, to the first formula, and use this one. With the exception, the only condition here says that n can never be equal to -1, but that's okay. My n is not a -1. It's a negative number, yes, the exponent, but it's not -1. It's another negative exponent, which is okay. So then I'm gonna use x raised to the n. Formula says 1 over n plus 1 times x raised to the n plus 1 plus the c. So that's what I'm gonna do for this problem. The integration of this is going to be 1 over, what's the n? The n is gonna be, as weird as it's gonna look like, -1/3 plus 1 times x raised to the n, so raised to the -1/3 plus 1. Because this is the only thing you're doing the integration of, you can already put the plus c. I didn't want to put the plus c in the other problem every time that I was doing every formula separate, because it was more than one term. There was plus and minus, minus, plus, and that would separate the terms into different ones, right? And I needed to do each term on its own, doing the integration of. But here it's a single term, so you can already put the plus c. And we don't have a value for c, so then c is gonna have to stay as being c. Now simplify this. -1/3 plus 1. Either you use the calculator to come up with this answer as a fraction, or then you do it by hand. It's up to you. The thing is, you should understand that if you convert this 1 into thirds, this is 3/3. So -1/3 plus 3/3 should be 2/3. Again, put it on the calculator if you're like, what? How do you know that's 3/3? But put it on the calculator. -1/3 plus 1, because you just did the answer here, right? It's 2/3. So then this is raised to the 2/3 plus c. Now what's the only thing left to do? Simplify that division. Change to the reciprocal, change the division to multiplication, and do the reciprocal of this. So then final answer should be 1 times 3/2. This is just gonna be 3/2. X raised to the 2/3 plus the c. Okay, and that would be the answer. Using the power rule formula for the antiderivative. And what else did I have to do? Did I have that one to do? Because I had already shown you how to do the integral. Well, when we didn't know the symbol of the integral, but I had already gone over this problem. This one that had a trigonometric function, or I had already gone through this one. It's just back here or back then, we didn't know about the integral symbol, but it's the same thing. So I'm gonna skip actually this one. That was here, by the way. This one, I'm not gonna do it. This problem, put a mark on it if you have the copies of these notes with you in there, if you printed this already. And if you didn't print it, then copy it down. Make sure you copy it down, because this is a problem that I'm gonna give you as homework, as written homework. Today, before the end of today, before 11:59 p.m., send me the answer for doing the integral of this problem to my email. Okay, so this is one problem that I'm assigning to you already. So I'm not gonna do it because I already did some examples using finding the antiderivative or doing the integration of a function that has a trig function, and it's super simple. So this is one of the ones that I'm gonna let you do as homework, and you send it to me before the end of tonight. This one I will do because it's a little different, okay? It's a different formula. Let me do this one. Let me just make sure, yeah, I'm there. So for this one, what formula am I going to use? Be very careful. Don't say, but you're gonna use the power rule because there's an exponent, 3 raised to something. Wait, when you use the power rule, it's because you have x raised to a number, not a number raised to x. So don't confuse it with x raised to something. This is not the formula you're gonna use. The formula that you would use, because your base is not an x, your base is a 3, and the exponent n, it's not a number, like that would be for number 1. When the exponent is a number, you use number 1. But when the exponent is not a number, the exponent is something like x or anything else, then you're talking about this formula right here, number 13. So I'm gonna, and this would be obviously the antiderivative for this. I'm gonna copy this formula. A raised to the kx, whose antiderivative, it's gonna be in parentheses 1 over k times ln of a, 1 over k times ln of a, times a raised to the kx plus c, times a raised to the kx plus the c. And there were some conditions or restrictions where a always has to be a number that is greater than 0. That's how I knew also that I needed to use this formula. A, which is my 3, it's a number that's greater than 0, okay? And also a can never be equal to 1, and a wasn't 1. So that's how I knew this formula and not the powerable. So what do I do next? I'm gonna start doing the integration using this formula. So 1 over k. What's k? K is going to be the number, the coefficient before the x. So here, the coefficient before the x, we should all see how that's a 1, right? 1x. So 1 over 1 times the ln of a. What's my a? My a is the 3. So ln of 3. All this in parentheses, it's gonna multiply times a raised to the kx. What's your a raised to the kx plus the original thing you started with? Times 3 raised to the x or to the 1x if you wanna put it like that. Plus c. You can already put the plus c because this is the only thing you have to do the integration of. So simplifying on the denominator, what's 1 times ln of 3? Simply natural log of 3, right? And this is a natural log. It's not an I or something. It's the L for natural log, okay? So 1 over this, it's this fraction, and that's multiplying times 3 to the x. So what I would do if I would be you, I would put this over 1 and multiply numerators and denominators. So this would be 3 to the x over ln of 3 plus the c, and that's it. We leave it up to here. We're not given any specific value to replace the c by, so I'm not gonna be inventing numbers. That's what it is, end of the story, okay? Let me see if I'm missing anything else to do. Okay, I think I have time for one more problem. So let's look at something like this one. Should we do that one? Yes. Okay, for this one, you have to do the antiderivative of this, okay? So there's a minus. That means that you should consider this problem as you're gonna have to do it in 2 steps. You're gonna have to do first, what's the antiderivative for this? What's the antiderivative for this? But before I get into that, what's the formula for the antiderivative of cosine of whatever? So the antiderivative, where was it? For cosine of whatever in the angle, it's here. Cosine of kx, antiderivative is this. So I'm gonna write all this in the slide where I was right now. Cosine of kx, antiderivative, it's gonna be 1 over k times sine kx plus c. 1 over k times sine kx plus the c. This is the one that I'm gonna use for the antiderivative of all this. What is the formula for cosecant square of whatever angle? Do we have a formula for that? Cosecant square of, yes, we have that in here. Cosecant square of kx, let me copy that in here. So for this one, cosecant square of kx, the antiderivative of that, it's going to be negative 1 over k cotangent of kx plus c. Negative 1 over k times the cotangent of kx plus c. Okay, so I'm ready. I have the 2 formulas that I need. So the integration of this piece by piece, remember, first, you're gonna separate this as do the integral of this with respect to x, so you put your dx, minus, because that's the minus you have here, minus the integration, you write the symbol again, of cosecant square of x dx. And then you start doing it piece by piece. So for this one, what's the formula that I'm going to be using? This one right here. It says 1 over k. What's my k? The 4 times sine of 4x, kx, right? You don't need the dx anymore. You already did the integration of this. Remember that I'm supposed to put a plus e, but I'm gonna hold on to putting the plus e, okay? Until my final answer when I put all together. Minus, what's the antiderivative of this? Here is the formula. There's a minus you had to bring down because there was a subtraction of these two terms, but then this has a negative at the front, so be very careful. I'm gonna open a parenthesis, minus negative 1 over k. What's my k? Whatever the value is in front of the x. What's the value in front of the x? Even though you don't see it, it's a 1. So negative 1 over 1 times cotangent of kx, because your kx is just the x, 1x, right? So now, and I add my plus e here at the end of the whole thing. So 1/4 times sine of 4x. Here, what's going to be 1 over 1? 1. And what's a negative times a negative? It's a positive. So plus cotangent of x plus c. And this is it. This is my final answer for the integral or the antiderivative of this one. Okay. Let me see if I can have time. I think I would have time for doing this one. I don't know if I have time to explain this. Okay, no, I'm gonna stop here because there's not gonna be enough time and I'm gonna rush through this. So I'm missing a few more problems that are a little different from what I've done. So the only thing that I'm going to ask you for today, guys, right now, as soon as we finish the lesson, if you wanna do the problem, the only problem that I gave you to do today was this one. So I want you to do it in a piece of paper, show me every step, super simple, send it to me via email before midnight. As soon as you have it, send it to me. The next thing that I want you to do, the Math Excel for section 4.8, it's already done. It already has a due date in there. It says that it's gonna be due by the 6th. So the 6th should be the next time that I meet with you, I think, or not, maybe, I don't know anymore. Yes, the next Wednesday when we meet again. By that day, everyone should have already worked on the 4.8, but let me tell you up to where, because there's from a certain problem and on, I need to explain the problems that I didn't get to do today, okay? So I think if I'm not mistaken, let me see, 16. I'll tell you right now. Is there a formula for the tangent on its own? If there's a formula for that one, you can do that one as well. Oops. Tangent square, where is tangent square? No, you're gonna need a formula that I need to teach you for that one. Okay, so then you're probably not gonna be able to do this one. You're probably not gonna be able to do this one. For this one, secant, tangent, I think you have that formula there. Secant, tangent, yes. Okay, so everyone's gonna be able and should be able to do with what I've taught you today up to problem 15. Okay, take a note of this. Up to problem number 15 is what everyone should do by the time that we meet on Wednesday. Next time, I'm gonna check that everyone has done up to number 15. 16 up to 20, so the last 4 problems. I need to go over the last part of 4.8 for you to be able to do those problems because you're not gonna be able to, okay? Because we're missing stuff. So 2 homeworks you have that I'm leaving you. 1 homework, it's due by midnight, okay? So do the problem that I gave you to do, which was this one. It's in your notes. In a piece of paper, you send it to me. Second homework is gonna be working 1 up to problem number 15 on the 4.8 Math Excel. And I know the due date says for the whole thing is the 6th, and I'm gonna leave it like that, but just working up to number 15. Then I'll reopen it again for you to do the last 4 problems. After on Wednesday, we cover the last section, the last part on this section. But it's gonna close on Wednesday, and I'm gonna check that everyone did up to number 15, okay? Any question as far as the homework or any problem that we did today?
Ms. Rangel,
Yes.
¿Cuándo va a poner de que los grados de los otros Math Excels los
I
ya
need
había?
to go back and see who did all the things that you guys didn't do on time, and I know I just need to pass them. They're there, but I haven't passed them to the gradebook, but I will update it.
Okay.
Any other question, guys? Homeworks? Anything that you like? You have two homeworks, okay? Just want to make sure you understand that. So let me just see who was
Miss
here.
Sanchez,
Yes,
it's also the 4.5 Math Excel due Sunday, right?
yes, the 4.5 we said that is due this Sunday by midnight. Completely the 4.5, all of it.
Thank you.
You're welcome. So if there's no more questions, guys, then this is it for today. We're done. And I'll be uploading the video link in a little bit more to YouTube and send you the link. Bye, take care.
Bye, Miss.
Bye,
Gracias.
Bye.
Bye, ma'am. Thank you.
You're welcome, bye-bye.